Hello, in this video we will be finishing our applications of symmetry and discussing selection rules and decomposition of a direct product. And in today's exercise we will be focusing on something that has PD symmetry, something similar to methane. So in this discussion we have a simple question. Will a photon be absorbed? And typically we've been drawing two-level systems in the past, and let's say that's A1 and A2, and we typically draw our vertical arrow and say, okay, we've got some absorption event. Well, if we drew that and the arrow allowed that to occur, then we would say that is allowed. On the other hand, if that particular transition was unallowed, we put an X through it. Right now, what we want to do is try to understand what is the basis for this understanding for an allowed or unallowed transition. Discussion should begin with the transition dipole moment. Remember that electron is a movement of charge across the molecule, which has an inherent dipole between the positively charged nucleus and our electron, and so is most adequately understood by that dipole moment. Typically, we summarize it along the z-axis is equal to negative E, which is our charge, integration across all space, psi f star, z psi I, d tau. Psi I is our initial state of our wave function. D can be understood as the operator along Z, which connects psi I and psi F, and this is our final state. E is our charge, and of course mu sub Z is our transition dipole moment. So when mu of Z is not equal 0 for a transition, to occur, it must be non-zero. You should be convinced by now, especially with these arguments that we've been using for symmetry, for the integrand to be non-zero, symmetry must be A1. If you don't understand what I'm saying, you have to go back to the video before to make sure that you are well aware that we have to have A1 symmetry or some equivalent to A1 symmetry. Okay, let's do an example and go through the process. The question that we have is the px to py transition allowed with an underscore transition in a tetrahedral molecule like CH4. Recall that CH4 would be in the PD, of course, tetrahedral, PD, so we'd be looking at that character table. So step number one, we need to set up our equation and see what that looks like. We know that it should be our transition dipole moment, our integral, and in this particular case, it's py at z component px d tau. And we're wondering whether or not it equals 0, or it is a non-zero answer. You have to set up the product table. For Py, Z, and Px using our TD character table. Okay, by looking at the TD character table, we can see that X, Y, and Z components are all in the P sub 2 symmetry species. So that's that's our function. So each one of these, this is F1, F2, and F3, are all coming from D2. We can go ahead, look in our character table for TD, and there's 5 classes. We've got E, we've got C3, we've got C2, our dihedral, as well as our improper rotation. And for P sub 2, those values are 3, 0, -1, 1, -1. Okay, then in step number 2, we're going to take that component of our TD and set up our table. And we've got 3 functions. We're going to multiply them. Again, we've got our classes that are up top. And for each one of those functions, F1, F2, and F3, which could be our Px, Z, and Py components. Of course, we're saying that they're all matching. They're finding the product of each one of those. 27, 0, -1, 1, and -1. This is our product similar to what we did in the last video. So this is the product of F1, F2, and F3. Okay, now 27, 0, -1, 1, -1 isn't obvious that we would have any A1 symmetry in there. So step number 3, we need to use the decomposition of a direct product. The question that we're asking is, does 27, 0, -1, -1 contain an A1 symmetry, which of course means 1, 1, 1, 1, 1 for TD. Mathematically, this is understood by taking the summation of these products, their characters, based on the symmetry operations of those characters, finding out if in fact we've got some addition of A1 within that direct product. And we're going to go through those steps. Okay, in order to do the decomposition steps, we're going to once again set up another table. Now this table is going to include, once again, our classes. Excuse me, that's a C2, our dihedral, and our improper. And in line number 1 is going to be that function that we just created, that direct product. We're going to go ahead and put in the values that we just achieved. And then we're going to put in line number 2 at A1 symmetry, because that's the question that we want to ask. Is this other symmetry a part of this function F1, F2, F3? Again, we create a product, 27, 0, negative 1, 1. Oops, I forgot a negative sign there. This is negative 1. Step number 5, we sum up all the products. That sum is equal to 26. And then we take that sum and we divide it by the order. And you'll recall for TD, the order is equal to 24. So we take the sum, we divide it by the order H, which is equal to 24, and we get a value that's approximately 1. In this particular case, A1 occurs once, we get that value from right here, once in the set of characters, and therefore the PX, PY transition is allowed. Now let's make sure that this process is well understood because we may be seeing this in the upcoming exam. If you have any questions on this video or the other symmetry videos, please contact me. Thank you very much. Bye-bye.